So, from our two examples, you have one that it shows where things are not dependent on each other. The cats and owning pets has nothing to do with your grade level. Whereas whether or not you have vacation and cable do kind of have a little bit to do with each other because they both involve money. So if you can find a common ground between the two, more than likely they are dependent upon each other in some way, shape, or form. What you might have started to notice is there is a formula for conditional probability. You don't just have to like randomly find things on the table or try and think too hard about it. The idea for finding conditional probability, if we look back at the example we did with the vacation and cable, to find the probability of vacation giving that the person had cable, we found the intersection of both. That was the top number, and it was out of the probability of how many people had cable. We knew they had cable because it's given C, that C is last, so that was automatically our denominator. And then we want to know how those people, how many went on vacation. So that's the intersection. So with probability of V given C, that second letter is always our denominator. So the total of cable is always our denominator, and then the top will be the intersection of the two. So in general, the probability of A given B is the probability of A and B over the probability of B, where, and you need to fix this in your notes, the probability of B cannot be 0, because if the probability of B was 0, you would have a 0 in the denominator, and that's not possible because we can't divide by 0 ever. So it's the probability of their intersection over the probability of the given information. So let's look at an example and show you how easy this formula is. In a survey of pet owners, 45 own a dog, 27% own a cat, and 12% own both. What's the conditional probability that a dog owner also owns a cat? So if you notice in this problem, there's no keyword. There's no given, there's no whose, there's no assuming anything based off just the words. However, it calls the person a dog owner. So that means the given part is that they have a dog. So that's our G. So what this looks like is the probability that someone has a cat given they're a dog owner. So this part shows ownership. So the fact they have both is 12% out of how many have a dog, that's 45. 12 out of 45 is 26.6 repeating percent. Well, then what's the reverse? What's the probability that a cat owner also owns a dog? We're calling the person a cat owner, so it reduces it to that 27% population, but the fact that they also own a dog. So this would be the probability of D given C, or 12 out of 27, which is 44.4% repeating. Are these events independent? Remember, the rule for independent is that the denominator does not affect the probability. So in this case, the probability of owning a cat given you own a dog, is it the same as the probability of owning a cat? Meaning, are these two the same? They are really, really close. Is the probability of owning a dog given that you have a cat the same as probability of just owning a dog? Does the denominator change anything? Are these the same? They're very, very close. So the idea is, are these events independent? No, they're not, because they're not exactly the same. They're close, but they're not the same. And if you think about it logically, some people are just dog people, some people are cat people. Dogs and cats don't always get along, so they are dependent on each other, dependent on what the pet owner likes, dependent on the animal itself. So these are not independent events based off this information, because even though they are close, they are not exact. So now, let's look at tossing some coins. We're tossing 3 coins and recording the sequence of heads and tails. A is the event of getting at least 2 heads. B is the event of getting all 3 coins to be heads. So first off, what's the sample space? Well, the sample space looks like this. Heads, 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 and so on. There are only 8 different outcomes of what could actually happen. Then we're asked probability of A given B, probability of B given A. So the probability of A given B is the fact that at least 2 and 3 heads occur. Well, only in one case out of the 8 does that happen, and that's when all 3 heads occur, over the probability of getting 3 heads, and that's 1 out of 8, which is 100%. So the idea is the probability of getting at least 2 heads, given that you've got 3 heads, is 100% because you know you have 3 heads, so you have at least 2. Finding the probability of B given A is the probability, again, that you have at least 2 and 3 heads, given the fact that you have at least 2. So that one's a little bit different. There's only one case where you have 2 and 3 heads, and that's all of them being heads. Whereas there are 4 possibilities of you having at least 2 heads. That being this case, this case, this case, and that case. So it's 1 out of 8, or 4 over 4 out of 8, which is 1/4. So the idea is, if I reduce my sample space to at least 2 heads, there's your 4. How many of those have 3 heads in them? That's the first one, which is 1 out of 4. So that's an example of with coins. Note, order events matter. Conditional probabilities are not symmetric, meaning if A equals B, then B equals A. You cannot flip-flop these two. A given B is not the same as B given A 99% of the time, and we just showed that in example 7. Now I want you to try the one about shoppers and whether they use coupons or a shopper club, or the fact that they use both. Pause the video at this time. If you have questions, ask Miss Lewis. Try the try before checking your answers, please. So, in the try, we are told 54% use coupons, 36% belong to a shopper club, 18% do both. So the first one was a conditional probability that a shopper uses coupons given that he or she belongs to a shopper club. So that would be the probability of C, representing coupons, given SC, so that's a shopper club. And I literally just wrote what I read. Coupons given shopper club. Well, by our formula, it would be their intersection, which is 18%, over the denominator, which is the shopper clubs, which in this case is 36. So 18 out of 36 is 1/2, or 50%. B is what is the conditional probability that a shopper belongs to shopper clubs given that he or she uses coupons. This is just the reverse. The intersection is still 18, but this time we are assuming that they use coupons, which is 54%. That is 1/3, or 33%. Are these events independent? Remember, the rule is if they are independent, the denominator doesn't matter. So in this case, does this probability equal coupons? 50 does not equal 54. In this probability, does the same probability of the condition equal shopper club? This does not equal shopper club, so no, they are not independent. A lot of people kind of do both, or refuse to do one or refuse to do the other. So there is some dependency between using coupons and being a member of a shopper club. Alright, next, try the next try, which is about a jar of marbles. There are 2 different color marbles and 2 different sizes. So see if you can do the conditional probability of those, and then answering question C is very similar to what's on your final exam. Pause the video. If you have any questions, ask Miss Lewis, and then check your answers. So, the idea in A and B is the probability between getting a large marble, given that you're given a red, and the probability of getting a large marble, given that you have blue marbles. So in A, our denominator is red. There are 14 total red marbles. Of those red marbles, 10 are large, so it's 10 out of 14, which is 5/7. In B, same type of thing, we're just looking at the blue marbles. There are 11 blue marbles total, and 6 out of those 11 are large. So 6 out of 11 is your probability of getting a large marble, given that they are blue. The last question asks, do you have a better chance of getting a red marble given that it's small, or getting a small marble given that it's red? So the first looks like this. These are our 2 conditions. Red given it's small, or small given it's red. Well, there are 4 red and small marbles, so that's the 4. Given that it's small, well, there are only 9 small marbles, 4 red, 5 blue. So that's 4 out of 9. The other way says being small given that it's red. Well, there are 14 red marbles, 4 of which are small. So that's 4 out of 14, which is 2 sevens. Obviously, 4 out of 9 is greater than 2 out of 7, so the greater chance is getting a red marble when knowing that they are small. And that's because there are more red small marbles. If you have any questions on the you try, please ask Miss Lewis. Now, let's talk about everyday life. So, example 8 talks about Michelle and her emails. We get emails all day long, and a lot of them are spam. For Michelle, 10% of the emails she gets are spam emails. Her spam filter catches them 95% of the time. However, her spam filter misidentifies them 2% of the time. Let A and B be the event that the email is spam, and B be the event that the spam filter identifies it as spam, so meaning it identifies it correctly. Question 1, or A, says, what does it mean in your own words? Well, it tells you in the words that A is the event that the email is spam. So in my words, it's the probability that Michelle receives an email that is spam. Easy peasy. Question B, what's the probability of B given A? Well, B is the probability that the email is identified as spam given that the email is spam. So it's the idea that Michelle's email identifies the email as spam given that it received a spam email, or it identified it correctly. What does B not A mean? Means the probability that Michelle's email identified it as spam, but it wasn't spam, meaning it identified it incorrectly. So that's that 2%. All right, next I want you to try the you try about Carl taking the bus to school and whether or not he is late. If you have questions about example 8, please ask Miss Lewis. Please pause the video at this time before checking your answers about Carl. So, in the you try, Carl takes the bus to school. Each day there's a 10% chance that the bus will be late, a 20% chance that he will be late, and a 2% chance that both he and the bus will be late. B will be the event that the bus is late, and K will be the event that Carl is late. So what's the probability of B? Well, 10% chance that the bus is late, so that's 10%. Probability of K, well, that's 20%. That's the probability of Carl being late. Give you that in the problem. Then what's the probability of B and K? That's 2%. So we're not doing B's and B's in these cases. We're doing change these letters to K's. That's a typo. Question B says, what's the probability of B given K? So if you remember our formula, that would be the probability of B and K, or 2, over the probability of K, or 20. So 2 out of 20 is 1/10, or 10%. Are B and K independent? Remember, the definition of independent is the given. The denominator doesn't change the fact. So, is the probability of B 10%? Yes, with this. So this question is actually yes. They are independent of each other. And I don't know where my pen went. Here we go. So this is actually yes, because these two are equal. Alright, then find the probability that Carl is not late and that the bus is late. So the probability of not K and B, we go back to what we did yesterday. And means to multiply. If the probability of Carl is late is 20%, then that means if he is not late 80% of the time, so that's your 80. And B, well, B is just 10. Why did I put a 2? I'm not sure. Probability of B is 10. So then we would multiply these two. 0.8 times 0.10 is 0.08, or 8%. If you have any questions about this you try problem about Carl and whether or not he's late by the bus every day, now is the time to ask Miss Lewis. If not, complete your assignment on conditional probability. Tomorrow you will review everything that is needed for your probability test on Thursday. Thursday is your last test of the marking period. So please make sure between today and tomorrow that you get all your questions answered.